Okay, and finally, in terms of the rate of reaction, we also want to have a look at these changes being affected by concentration, temperature, pressure, state of subdivision of reactants, and really what we're talking about there is surface area, presence of a catalyst, and this includes enzymes, and intensity of light. So what we're really interested in is what's the likelihood of the collisions being productive. So to have a successful collision, to have successful collisions that result in our products forming, this is determined by the frequency of the collisions, the orientation of the collisions, the energy of the collisions, and the activation energy required. So if we increase the concentration, so that's the more bits in a certain area, so if we start off with our reaction vessel and we increase the bits in there, which is our concentration, there is a heap more chance that they're actually going to collide with each other because there's more bits in there. So we're going to get increased frequency of collisions. If we increase the temperature, we have these bits moving around faster. So as they move around faster, we are more likely to get collisions, therefore more likely to get successful collisions because we have increased number of collisions per unit time. Similarly with pressure, if we have bits again, now pressure is only relevant for gases, if we have less space that those same amount of bits are allowed, which is increasing the pressure, we are more likely to get them to collide. So we're going to increase the number of collisions per unit time. Similarly, if we increase the surface area, and that's by turning something into a more powdered form or getting things that are smaller bits, we're going to increase the area for colliding, therefore increase the number of successful collisions. A catalyst lowers the activation energy. So catalysts provide an alternate pathway with lower activation energy. And light intensity works similarly to temperature. So for a chemical reaction to occur, as we've said before, we have to have collisions with the correct orientation, and this is particularly important when we're talking about larger molecules. So in organic chemistry, only particular parts of the molecule can collide. So that's why it's really important that they have correct orientation, and they must have enough energy, which is our activation energy. So here's a summary of what I just said. Be an idea to have these in your notes and to make sure you understand what this means.